Hello, everybody. Today, we'll be looking at OOP concepts in Python. We'll be doing a deep dive in OOP concept in Python. So my colleague has introduced classes in Python. And today, we'll be going in a little bit more into what you can do with Python and the OOP concepts, right? So I'll be starting with the class itself. So this is how we do a class keyword and just say dummy class, right? So the class itself is a way of creating templates for things that you want to build on. So in the sense that, let's say you want to build a house, right? You have this house you want to build. You need an architect to come and design the house. So the design of the house is the template of the house, right? It shows who's going to build the house on how to build the house, right? When you create a template of the house, right, is when an architect designed the house, is creating a template of the house, right? And that is what we call a class, right? The class is a way of showing that I want to create this object structure, right? And this object structure should have these features and it should have these attributes, right? It doesn't, when you use a class keyword, it doesn't create the class, right? It does not do that. It just says that there's a template on how to create a class. Now, when you create the class is when the class is being called, right? It's when you call the class is when you're actually instantiating the class. This is when you are making you're making the building itself, right? So if you have an architect that did like designed 2-bedroom flats, 3-bedroom flats, right? It's just the design. It's not in the physical form, right? So that is what the class is. But when the class is being called or instantiated at runtime or anytime at the lifetime of your product, then that is when you can say that, yes, you've actually converted your template into actual working code. So in classes, we have what we call instance variables and class variables, right? So I'll start with class variables. Class variables are defined within the class construction because they are owned by the class itself, right? And class variables are shared by all instances of the class. Do you get now? So therefore, they will generally be the same value for every instance, right? So what they're trying to say is a class variable is defined within the class construction. So I can say class animal, right? So this is an animal class. I can now say the instance, the class variable should be animal type, right? I can say the default animal type is, let's say, insects, right? So this is a class variable. This variable is actually around throughout the lifetime of the class. Each class that you're being instantiating carry this along with them, right? They have this with them. So a good example is if I say, so did also, when you want to, so initially in the other class, let's say we do animal 1 and we say animal, you have to do something like this, then you can now do print animal 1, right? So print animal 1 dot animal type, right? So if you do this, it's going to print insects, right? Based on what we have here. Now, the beauty about instance variables are you don't need to instantiate the class. So when you do this, you're calling the dunder underscore call magic method in Python. And this is saying, okay, I want to instantiate this class. You don't even need to instantiate the class, right? Since this is a class variable, you can just do animal, you can just do a print animal dot animal name, and this is going to animal type, and this is going to work because animal type is tied to the class. This is a class variable. Please take note. Now, what are instance variables, right? Instance variables are declared in the constructor method itself. And in Python, the constructor method is the underscore underscore init method, right? So that is a magic method. That is being called when you're trying to construct the object, right? They are called instance. So when you're creating an instance of an object, you call them instance variable, right? And they are tied to that particular object. They are not tied to they're not tied to multiple classes, right? When you instantiate, they are tied to that object in the memory, right? They are not tied to multiple instance of the class. What does that mean? So if I call the def underscore underscore init method, right? And I say this should have a name, this animal should have a name, right? Let's change this to a mammal, right? This should have a name. So they are always, so for you to differentiate an instance variable from a class variable, they are attributed with self, right? Self.name, and we call it name. I believe this is what we are used to. We are used to this, right? This self.name is an instance variable because this is tied to the class, like to the object of the class when it's been instantiated. So when I instantiate a class called animal, this name is tied to that animal. So what do I mean? If I do animal one, let me show something. Animal one equals to animal, then the name of the animal, let's just say rat, right? Yeah, one is currently disturbing me though. So I'm saying animal two, let's say it's animal, yeah, what's the best alternative to rat? Let's say cat, right? Now, what I'm trying to say is this line and this line are instantiating this class in the memory. Now, when it's instantiated for the animal one, rat is passed into the init method and is assigned to the self.name. But look at something. If I should print animal 2.name, sorry, animal 2 dot type name, animal type, and I print animal 1 dot animal type, you would see that they are both mammals, right? That is because this animal type is tied to the class object itself, right? Not the instance of the class object. Very much important. They are always available as long as the class object itself is available, right? So a good example of how to use an instance, how to use a class variable, right, is let's say I want to keep track of how many times animal is called, right, throughout the lifetime of my program. So I can have multiple files, like 6 to 7 files, and animal is being called in those files, right? And I want to keep track of, okay, how many times is animal being called in my program, right? So what we can do is we just need to use a class variable. Since classes are attached to an object, no matter where they're being instantiated, the first thing is you know that you need to assign it to a class variable. Let's call it a counter, right? And we initialize it to 0. So here, when an object is instantiated, right? When we create an object, we just have to do what? Increase the counter. We just do animal dot counter plus or equals to 1, right? This increases the counter for every object instantiation, right? We just increase the counter. So for line 10, this is going to increase the counter by 1. This is going to increase the counter by 2, right? So if I come here and print, if I come here and just print animal dot counter, I should have 2, right? I should have 2. So I can use this to check the number of times an object is being instantiated, or let's say an object is being called in the program, right? A class is being called in the program. We can use this to actually track that, right? Very, very much important. Now, we're moving to different type of methods, right? We have in Python. So we have 3 type of methods in Python. We have the, so let me write here. We have the instance method. We have the instance method. We have the class method. We have the instance methods. We have the class method, and we have the static methods, right? So these 3 methods are what we currently have in classes. So what are instant methods? They are the most basic methods that you would see most of the time. So in our last class, where we had classes, we were used to, so we can add a method, right? So we can add a method called legs, right? We can add a method called legs, or we can just say can run, or let's just say the method called can run. You can see by default, an instant method has what we call the self. So you can see everything about instances have what self with them. It means that for every object that is being instantiated, this method is attached to them, right? They have their own methods attached to them. So this one has its own can run, this one has its own can run, right? So you can see the methods take one parameter self, right? Which points to the instance of the class when the method is called. So this is going to have, so let's say, let's make this robust. We can say name, and we can say legs, right? Or we can say number of legs. So we can do self.number of legs equals to number of legs, right? So here so the instance method can take a number of arguments too, right? Or a number of parameters. Remember I told us difference between parameters and arguments. So we can take a number of parameters, and we can say can run, and we can do, we can just say self, then we can just say print, format string animal name, sorry, self.name runs with self.number of legs, right? So here we can see that we have rats. So let's change this to n. Hen, how many legs does hen have? He has 2 legs. Then let's say cat has 4 legs, right? So we can say, we now call this animal 1. We can say animal 1 dot can run, right? Then we can say animal 2 dot can run. Now, if we call this, we can see that. So let's differentiate this with equals to, and do let's do this. Let's print equals to 20 times. So to differentiate, so you can see that animal hen runs with 2 legs, animal cat runs with 4 legs. So you can see that for every instance of animal, right, we are calling can run. You can see that the can run is different for each instance of the animal, right? For the n animal, we have 2 legs. It's printing the self.name. that's hen, and it's telling us it runs with what number of legs? Has 2 legs. Then we're saying the cat has 4 legs, and it's the cat's also the animal cat runs with 4 legs. Now, that is this is an instance method, just like how we have our instance variable where they're also attached to the instance of the class, right? Now, what does this give you? If I say a class method, right? Class variable, class method, class variable, class method. What does it mean? It means that the variable, the class method is attached to, is the same thing for every instance of the objects that we're creating, right? So hen or cat, or if you say we want to create dog, right? We want to name this animal 3, right? The dog has 4 legs. So if we want to do that, if we're attaching a class method, right? It means that this method is going to change the state of the class no matter how many times you've called it, right? And how do we define an instance, a class method? We just use the @ we call the decorator class method. Then we just say this is going to be a class method, and we say, so what is common between all animals? What is common? We can say eyes, right? They all have can see, right? So we can say can see. So you can see attach a CLS. This CLS is an attribute to the class itself, right? So we can just say print animal can see, right? So if I call this, so remember I said we are regardless of the objects that we created, a class method is attached to all of them. It comes together with all of them. So I should not have different things for animal 1, animal 2, animal 3. So if I should come here, I copy this, let me increase the number of, so let's say this is 40. Then if I say animal 1 dot can see, right, is a class method. I say animal 2 dot can see, animal 3 dot can see. You would see that they are all saying animal can see, animal can see, animal can see. We use this to modify the state of the class, the general state of the class, right? So let's say we have multiple classes defined everywhere. We use the class method to change the state of the class everywhere. So every place that the class is being instantiated, this can see is going to reflect in all of them, right? So that those are class methods. Now, static methods, right, are not really attached to the class, right? They are free on their own. They are more like your normal functions, right? They don't have any attachments to your class. They can be called. They can be called anytime. They don't just have any attachment to the class, right? So what does that mean? It means that if I have a static method, right, and I say def tail wiggle. So you can see that does not take either class or self, right? It's just on its own. You can just do a print animal can wiggle. Can wiggle its tail. So what this is trying to say is that this static method is just attached to this class that I just wanted to do one thing for this class, right? So there are a lot of arguments between Python developers. They tell you that, Why are you attaching a static method to a class? You can just take this out as a function on its own and call it whenever you want to use it in the class, right? But most times you want to attach a static method to a class because it makes sense on what you're trying to do for that class, right? So for example, this tail wiggle, it makes sense that we are trying to see that, yes, these animals that we're trying to instantiate should be able to wiggle their tails, right? So that is these are the methods that we have in Python, right? So the next thing we'll be looking at is inheritance and composition. So inheritance and composition is very simple. When they say inherit, they're trying to say there are two classes, but let me create a file. So when they say inheritance, right, they're trying to say that the inheritance model, what is called is a or is an relationship. So a dog is an animal, right? A hen is an animal, right? A chicken is an animal. Or let's say, let's use the concept of office, right? We have employees and we have different sections in the office. We have the salary workers, we have people that are paid, we have people that are paid weekly or monthly, right? So these people are still part of employees in the company. Or we have different kind of cars, right? Mitsubishi, BMW, we have Volvo, we have Peugeot, we have, we have Toyota, we have Hyundai. These cars are showing that they are all different kind of cars, right? So when we say inheritance, we basically say we have a base class, right? We have a base class and we have a subclass, right? So what the subclass does is for us to show that this subclass is inheriting from the base class, we just call the base class here, right? So the base class, the subclass is telling us that this subclass is telling us it's inheriting all the properties from the base class. So in this base class, let's say we have animal, right? And we have mammals. Mammals are type of animals. So we inherit from this, right? So what is trying to tell us that for us to have mammals, mammals are inheriting the properties, the attributes, the actions of what? Animals. Do we get now? So animals, we can have, we can say, can breathe, right? So we can just print can breathe. So here, if we do, for us to understand what I'm saying, I can now say mammal 1 equals to mammals. And if I say dot can breathe, right? So you can see that mammal 1, let me just return. Let me return this. So if I say mammal 1, if I print mammal 1, right, you would see that, sorry. So you can see that mammal 1 has access to the can breathe function because mammals is inheriting from animal, right? So you can see that mammals is inheriting from animal. It is collecting everything from animals. So it also has access to the what? To the can breathe function or can breathe method that we have in mammals. So the idea of inheritance is so that we can separate our concerns, right? Because not all animals are mammals, right? We have aves, we have we have aves are birds. So aves are different kinds of animals, right? So they have their own attributes. We can say class aves, or let's say birds. So birds are the same thing as animals, right? Then we can do something with that. So this is a basic inheritance in Python. Birds are inheriting from animals, mammals are inheriting from animals. So you can see now we can do specific things with mammals, right? So we can say def can run, or let's say uh, body size. We can say body size of this. We can now say all mammals should have body size greater than 3,000 kg, or let's say 40 kg rather. So we can just say return body size of 40 kg and above, right? So my analogy might not be correct, but you understand where I'm driving at. So as we can see, what we can have here is, I just try to chain. So we call this chaining. We can chain and chain and chain operators depending on what you're returning. So this can break is returning this string, which is why I can always reference, I can call it mama1 and it's printing out the can breed. So here I can call mammals, right? I can say print mama1 dot body size. You can see that it's just no class here has access to the body size. Even the base class, right, that we're inheriting from does not have access to the body class, because it is the super class, right? This is the super class, and this is just the subclass. It's accessing from the super class, and the subclass can also extend itself to implement other methods, right? If we add another method to the animal, you would see that this mammal class will have access to it also. So this is what we call inheritance. Now, inheritance brings a very highly coupled code. When you're coupling things together, the relationship, right? It's more like you're using hammer and nail to hold two woods together. They are highly coupled, right? It gives you some flexibility, but sometimes there are some things that you don't need to implement in the subclasses that are always added to the subclasses, right? So we ask ourselves, what are compositions, right? So composition is a concept that a model has a relationship, right? So in the sense that, sorry about that. So in the sense that the model has a, right? So humans, we have a heart, right? So we are composed of a heart, right? So the relationship between two objects, right, is with composition. So we can say we have it's not is a relationship. So kindly take notes. Inheritance is a relationship, shows is a relationship, right? Then composition shows has a relationship. Very important, right? Very important that we understand these two concepts. So the very good concept of inheritance is, I'm going to give an example of custom errors, right? So we can do what we call custom exceptions in Python with an inheritance, like inheritance hierarchy, right? So the first thing is, for us to be able to do custom errors in Python, we are going to be accessing the base exception class in Python for us to be able to do that, right? So in several occasions, we are going to be, most times you are going to be seeing yourself that you'll be using inheritance a lot, right? So let's say I want to throw a custom exception. Let's say I want to throw a custom exception, right? Say class custom exception, then I can derive that from exception, right? So I can derive that from exception and just do a pass. So to call this, I can just say raise custom exception, right? So that is going to call our custom exception, right? As we can see, I'm calling a raise and it's calling the custom exception for me, right? So I can say raise custom exception and pass in a message and say an error occurred. Right? So as you can see, it's telling me here that I raised the custom exception and I'm saying what? An error occurred, right? So examples of user-defined exception. So we can say, let me give an example. I can say this is a custom exception. Then I can now say, I can give instances of, let's say we are going to do something like simple math, saying value is too small or value is too big, right? So I can say number, let's give a variable number value equals to 20. Then we can now say while true, we keep doing this. So I believe we had a class on try and accept the last time. Then I can say input number equals to input. Then I can tell the user to enter a number, right? So I can now say if input number is less than the number that we have, or if input number is greater than the number value that we have, we should raise a particular exception, right? So we can say if input number is less than number value, right? Let's do a pass first. Then we can now say else. We can now say else if input number is greater than the number value. We can now say we would raise exceptions for this. So this is always going to be a string. What we can do is we can now wrap this in, and so we can cast this to an int, right? So casting it to an int, sorry, please. So we can cast this to an int and now check both values. So what is happening here is, so let me try to catch exception as underscore, then I can just pass, right? So what I'm doing here is I'm trying to raise exceptions, right? On if the value is small or value is big, I can now say class value too small exception, right? It should inherit from custom exception. It should inherit from custom exception and just a pass. And I can do a class value too big exception, then I can raise, I also inherit from custom exception, then I can also pass this, right? So what is going to happen here is, if the value is too big, I would call the value too big. I will raise the value too big exception. If it's too small, I'll raise the value too small exception, right? So all I just have to do is in this place, I will just raise a value too small exception. Then here, I would raise a value too big exception, right? So, sorry. So if it passes, I just break out of my for loop, right? If the value is the same, I just have to do what? Break out of the for loop. Now this is a generic exception class, right? This catches every exception that we are going to have in this try block, but it is too broad, right? It's always advised not to always catch exceptions that are too broad. Sometimes you might not know the kind of exception you're catching, so this might come in handy. So, but since we know the kind of exceptions that we're going to be catching, right? So we're just going to do, so I'll show us why that exception is handy in the first place. But so I'm going to do, since I raised this in line 19, I'm raising the value too small in line 19, I can now say except value too small exception, right? And I can now say print value too small. Here I can now do an except value too big exception. Then I can now say print value too big, right? So if, remember, we are breaking here, if it's correct, so we can just say print, hey, you got it correctly, right? So I'm going to show us what I mean by catching exception that are too vague, right? So I print, let's just print this underscore str underscore. So this converts this to a string, right? So if I should run this, it's telling me to enter a number. So remember, our number is 20. If I should put 10, you can see it's telling me value too small. You raise the exception of what? The value too small, and I had to what? Do a print. Then once it raises it and I catch it, it still goes back, and because we are saying while this is true, this will keep running until we've gotten the value itself, right? So if I do value 30, it tells me value too big. As you can see, if I do value 15, it tells me value too small. So this keeps running until I get it right. So I can now do, if I print 10, you can see, sorry. So okay, if I print 20, you can now see, hey, you got it correctly, and you exited the program, right? So this is a very good way on how to use inheritance. You can see we are inheriting from exception class, then our value too small, our custom error value too small, and our custom error value too big are both inheriting from the custom exception. So you can see this is a this is like a grandchild, then this is like a child, and this is a parent. Exception is the parent, custom exception is the child. And since value too small and value too big exceptions are inheriting from custom exceptions, they're called grandchildren. So this is a very good way on expressing, on using inheritance for anytime you want to use it. So I'm using exceptions as a good way to test, right? So let's look at composition, right? Let's look at composition. So composition right? So like I said, if I have class employee, right? Class employee and employee def init, my initialization, the employee should have a name, right? And department. So should have a name and department. Now the employee's name and department should be instance variables, right? So they will be called when you are instantiating the employee's object, right? So self.department equals to department, right? So we have this. This is an employee. So an employee needs to have a salary, right? So we can say salary. He has a salary. As we can see, we heard what I said, an employee has a salary. So his salary, right? We can now say self.salary equals to salary, right? Is anything wrong here? Okay, nope. So self.salary equals to salary. Then, so we can now say def. So we can now say check salary, right? So check salary is just going to, what is it going to do? We can now say self.salary dot check salary. Now we just return this, right? So now don't be confused. So now you can see that you ask yourself, this self.salary, right, is calling a check salary. Where is check salary coming from? It's coming from this salary object. Now we can now do a class called salary. Look at the beauty. So we can do a class called salary, right? We can say def underscore init, then amount. So we can now do self.amount equals to amount, right? So we can now say then we can do bonus. So we can do bonus. We can say self.amount equals to self.bonus rather equals to bonus. So we can now say def. So now see where this check salary is coming from, right? I can now say def check salary, right? I can now say return self.amount times self.bonus, right? So we can see, so in composition, we can see that the employee has a salary, right? Employee is composed of a salary object, right? So I can say new employee, or let's say marketer equals to employee. What are the attributes that he needs? Name. So we have Jones. Department is marketing, and salary. We don't know the salary objects to pass. So we can say a marketer salary should always be 400,000 naira, right? 400,000 naira. And the bonus should be 5%. Sorry, 5%. So, okay, so I will talk to us about type hinting in Python, right? So we can see now that I've created a marketer's salary. So for this employee to have this marketer as an employee, for us to have this, it must compose of the marketer's salary. Can we see? It must have it, right? So here I can now say print marketer employee dot check salary. So if I do the marketer employee dot check salary, has no attribute check salary. So let's see. Okay, so this is a typo. The typo I have is this is salary. So check salary. As you can see, it's already bringing it out for me. So if I should run this, you can see this is applying. So I can, to format this better, I can just do an F string. You can say marketer salary is this with a discount of self dot bonus, with a bonus, not a discount, rather with a bonus of this, right? So we can say market. So if you print this to be more readable, so you can see that you can say marketer salary is 200,000 with a bonus of what, 5%, right? So this was so this is the bonus, right? Sorry, this is the bonus for the, so it's supposed to be self dot amount plus whatever we have going here, right? So this is going to be 600, or sorry, this is going to be this is going to be 2 million. Okay. This is going to be like 2 million. Like, man, it gives a bonus of 5% though, right? So this is going to be like 2,400,000, right? This is the bonus, but the marketer is actually earning 400,000. Now, this is a basic composition, right? So with the basic composition, you can see that my employee has a salary, not, there is no is a relationship, right? You can't say salary is an employee. No, it does not make sense. But employee has a salary, right? So this is the basic show for composition. So yes, I believe that will be all for today, and good luck to everyone.